Manual infrastructure plan reviews are a primary cause of production outages. Automating these checks directly in pull requests prevents configuration drift and accidental resource deletions before they reach your main branch. The continuous integration pipeline must trigger on every pull request event. Use specific filters for paths to ensure that only changes to Terraform files initiate the expensive and time-consuming plan generation process. Avoid using long-lived secret keys in your runners. OpenID Connect allows your workflow to request temporary credentials from cloud providers like Amazon Web Services or Microsoft Azure based on the identity of the pull request. Initialization must point to a remote state backend to ensure the plan is calculated against the current live environment. Use a partial configuration to keep sensitive backend details out of the source code repository. Execute the plan command with an output flag to create a binary file. This file captures the exact changes intended, preventing any discrepancy between what is reviewed in the pull request and what is eventually applied.
Raw binary plans are not human-readable or easily parsed by tools. Use the Terraform show command with the JSON flag to convert the binary plan into a structured format for automated analysis. Integrate TFLint to catch cloud provider-specific errors that the core Terraform validation might miss. This tool identifies deprecated instance types or invalid resource naming conventions before the plan even runs. Static analysis tools like Checkov scan your plan for security misconfigurations. It can detect unencrypted storage buckets or overly permissive network security groups by comparing your configuration against hundreds of built-in security policies. TFSec provides extremely fast security scanning tailored specifically for Terraform. It is highly effective in local development environments and CI pipelines to provide immediate feedback to developers on their security posture. Open Policy Agent allows you to write custom governance policies. By evaluating the JSON plan against REGO rules, you can enforce organizational standards like mandatory resource tagging or restricted geographic regions for deployments. REGO rules should be written to iterate through the resource changes in the plan. Filter for resources being created or updated while ignoring those marked for deletion to reduce false positives in your reporting.
Conftest is a utility that makes running Open Policy Agent tests against structured files simple. It returns a non-zero exit code if policies fail, which automatically stops the pull request from being mergeable. Infracost parses your Terraform plan and provides a monthly cost estimate. This visibility ensures that developers and financial teams are aware of the budget impact of a pull request before the resources are provisioned. Set up logical gates that flag any pull request increasing the monthly spend by more than a specific percentage. This prevents one-way costs caused by accidental high-scale resource provisioning in testing or production environments. Use the GitHub Script action to post the results of your plan and security scans directly back to the pull request. This keeps all relevant information in one place for the reviewer to examine. Large Terraform plans can be overwhelming. Wrap the output in collapsible details tags in your Markdown comment so that reviewers can expand the sections they need to see without scrolling through thousands of lines. Color code the plan summary in the pull request comment. Use green for additions, red for destructions, and yellow for modifications to help reviewers quickly identify the most risky changes in the infrastructure code. In repositories with multiple Terraform projects, use matrix strategies in your continuous integration configuration. This allows you to run plan checks in parallel for different environments, like development, staging, and production simultaneously. For large repositories, use sparse checkouts to only download the necessary Terraform modules and files for the current project. This drastically reduces the time spent in the setup phase of your automation pipeline. Concurrent pull requests can lead to state lock errors. Implement a retry mechanism or use a non-locking plan if your backend supports it, though a locking plan is always safer for accuracy in high-traffic repositories. If a workflow fails unexpectedly, it may leave a lock on the state file. Your automation should include a manual trigger or an administrative script to safely release locks after verifying that no other process is active. Terraform plans can occasionally contain sensitive information, like database passwords. Ensure your runner is configured to mask these values in the logs and pull request comments to prevent accidental credential exposure.
Configure branch protection rules to require that your Terraform plan and security checks pass successfully before a merge is allowed. This hard gate is the final line of defense against infrastructure misconfigurations. Assign specific teams as code owners for infrastructure directories. This ensures that even if the automation passes, a qualified cloud engineer must still provide a human sign-off on changes to critical resources. Atlantis is a dedicated tool that runs Terraform plan and apply directly via pull request comments. It provides a more interactive experience for teams who want to manage infrastructure without leaving the version control interface. Running Atlantis requires a self-hosted server or a container that can receive webhooks from your Git provider. It maintains its own locking mechanism to coordinate changes across different pull requests targeting the same state.
If you use TerraGrunt to manage multiple environments, your automation must handle dependencies between modules. Use the run all plan command to ensure that changes in one module do not break dependent resources elsewhere. TerraGrunt can run operations in parallel, which is essential for large-scale infrastructure. Your pull request automation should leverage this parallelism while carefully managing the console output to keep the review process manageable. Automated plan checks also serve as drift detectors. If the plan shows changes that no one in the pull request authored, it indicates that someone made manual changes in the cloud console that must be reconciled. When drift is detected, you should either import the manual changes into your code or use the Terraform apply command to revert the cloud state back to what is defined in your repository. Retain execution logs for at least 30 days. These logs are vital for auditing and troubleshooting failed plan attempts, especially when dealing with intermittent network issues or cloud provider application programming interface timeouts.
When a plan fails, your automation should extract the error message and highlight it at the top of the pull request. This saves developers from digging through thousands of lines of logs to find a syntax error. Avoid using the target flag in automated plan checks. Targeting can leave your state in an inconsistent shell and often masks underlying issues that would only be caught during a full plan execution. Always pin the Terraform version and provider versions in your automation script. Using the latest tag can introduce breaking changes unexpectedly, causing your CI pipeline to fail without any changes to your code. Set up a provider plugin cache directory on your runners. This prevents the pipeline from downloading the same multi-megabyte binaries for every single job, significantly speeding up the initialization phase. If you use internal or custom providers, your automation must be configured to check private registries or local paths. Ensure your runner has the necessary network access to pull these specific binaries during initialization for installation.
The credentials used by your pull request runner should only have permission to read state and perform plan operations. Do not grant them the permissions required to modify or delete resources until the apply stage. Run your plan checks on ephemeral runners that are destroyed after each job. This ensures that no sensitive data or state fragments persist between different automation tasks, minimizing the risk of cross-pull request data leakage. A successful plan check cycle involves code validation, security scanning, cost estimation, and human review. This multi-layered approach ensures that infrastructure changes are safe, compliant, and within budget. Regularly update your policy rules and security scanners as new threats emerge. Automation is not a one-time setup, but an evolving system that protects your cloud environment as your infrastructure grows in complexity. With robust Terraform plan automation, your team can deploy infrastructure with the same confidence as application code. You eliminate the guesswork and ensure every change is documented, tested, and verified before it ever reaches production.